All right, hi folks, this is Larry Maslino. I wanted to record another video for Module 1, and this is on Section 1.14. By the way, remember, when you're working in Module 1, there are 16 sections here to cover, right? So you got to work through these 16 sections, and for each section, you look over the examples, of course, and then you complete what's called the participation activities and the challenge activities. And I want to go to one section here, and I want to come to these set operations. And so let me give you just a little background on a set. So a set is really just a collection of objects that have something in common. Let's say I wanted to create the set of cars. Well, the way you do this is you set up curly braces like this, and each item in the set is called an element. So here's the first element, and you put a comma, and then here's another element. For example, I could put cars, Camry, Mustang, right? These are all names of cars. Now, one thing about sets is you never repeat an element. So I would never put Camry again in this set because Camry should only appear once. All right, well, when you have these sets, you can perform a lot of different kinds of operations. And let me scroll down and show you some of the different operations in this table. So what you could do is form the intersection, the union, the difference, the symmetric difference, the complement, and so on. And let me explain this description. This description might be a little tricky to understand, so let me try to explain it a little better. Let's do an example. Let's do a set. Let's call it set A, and I'm just going to use an example here. Let me write out this example here. 1, 2, 3, 8, 9, 10. And let me write another set B. I'm just going to make up an example here. 4, 7, 8, 9, let's say. All right, well, first one says intersection. Let me do union first. Let's do union. Union is AUB. So this is easy to remember. This symbol U looks like the letter U, so it stands for union. What this says is combine all the elements from both sets. You can almost think of this as like an OR kind of connector. Combine all the elements from both sets into one big set. So let's do it. A union B. Well, I know I got to combine all the elements from both sets A and B. So I'm going to start out writing down all the elements from set A. 1, 2, 3, 8, 9, 10. But I also have to include as well all the elements from set B. So I'm going to include 4. Let me come here to set B. 4, 7. And now I have an element 8, but I'm not going to repeat 8 because 8 already shows up in my union set. Here's a 9. I'm not going to repeat 9 because it already shows up. So this is my answer for the union. Again, remember, you don't repeat elements in a set. So each element should only be showing up one time. All right, how about intersection? Well, intersection means include only the elements that are common to both sets. So only include elements in common. So we use this symbol. It's an upside down U for intersection. So what I want to do now is compare these two sets and ask myself, which are the elements that are in common? That means it's got to show up in both set A and set B simultaneously. Well, I'm noticing there's an 8 that shows up in both sets. That means 8 has to be in the intersection. I'm also noticing a 9 showing up in both sets. 9 gets included. That's it. There's no other elements in common, so that's going to be the answer to this one. Okay. All right, let me do one more example here. Let's do the difference. All right, so I'm going to come here to difference. It says A subtract B. So what it seems to be telling me is when you want to form the subtraction, it says the element has to be in A, but it can't be in B. So you can almost think of like doing a subtraction of one set minus another. So I'm going to include, I'm going to include 1 because 1 is in set A, but it's not in set B. So that's a valid inclusion for the difference. I'm going to include 2. I'm going to include 3. Now let me come here to 8. I'm not going to include 8 because remember, it has to be, an element here has to be not in B. You can almost think of it as if you take this 8 here in set A and subtract this 8 in set B, they kind of cancel out. Same thing with 9. How about 10? 10 stays because there's no 10 in set B. So here's my answer for the difference. Again, you can think of like subtracting the two sets, and the elements that are in common are going to cancel each other out. All right, let me scroll down and do an example here because I wanted to do this challenge activity. I think it was this one. Yeah, because this will give us good experience in these set operations. All right, so let me start here. All right, so they're giving me set A and set B. And the first thing you're asking is intersection. All right, so I'm noticing intersection. Well, intersection means the elements that are in common between these two sets. So I'm looking for any elements that show up both in set A and in set B also. So I'm looking for commonalities here. Well, I could see 4 shows up in both and 8 shows up in both, and that's it. So 4 comma 8. So that's going to be my answer for this one. Let me go enter it. 4 comma 8. By the way, you don't enter curly braces here in your answer because the curly braces are already placed by ZYBook. So no curly braces in your answers there because they're already placed there. All right, let's go to the next one. It says A union B. Well, A union B means combine all the elements from both sets together into one big set. It's kind of like everybody's jumping into. Let me start out with set A. I'm going to type 1, 6, 7, 8. I'm going to add in all the elements from set B, but I'm not going to add in this 1 because it's already there. I am going to add in the 4. I'm not going to add in the 7 because the 7 is already there. So the only extra thing I'm going to add here is 4. By the way, notice the order doesn't matter. So you don't have to put these elements in numeric order. They can be in any order. All right, let's keep going. This one says A subtract B now. Well, for A subtract B, again, let me, by the way, they changed the sets now, notice. So A is 2, 3, 4, 7. B is 2, 4, 6. So imagine doing a subtraction. Well, 2 subtract 2 would cancel out. 4 subtract 4 would cancel out. What I'd be left with is just 3 and 7. So the answer to this one should be 3 and 7. Okay, let's do a few more. All right, this one is kind of interesting. This says, let me clear the screen here. This one says B, and there's a plus sign and a circle around it, A. So let me write this down. A is 5, 6, 7, 8. And B is 3, 6, 8. All right. Let me go back to that table. I need to look up what does this symbol mean? A plus sign with a circle around it. So let me scroll back up and look for that. And I'm going to my table here. Here it is. I'm noticing it means a symmetric difference. And here are the instructions. For the symmetric difference, it says work out A minus B or B minus A. So I have to do these two subtractions. The word or, remember, means union. So I have to do these two subtractions and then combine those results together into one big set. So let's do it. Let's work out A subtract B. Let me scroll down back to the question. So we have it. Here it was. Let me get rid of this circle here. Okay. Oops. All right. Let's do B subtract A first. Doesn't matter, of course. We have to do both of them. So let's do B subtract A. And then we're going to do A subtract B and then combine these together. All right, let's do B subtract A first. Well, B subtract A. I would start out here with this 3. There's no 3, though, in set A, so I keep the 3. 6 would cancel out with the 6. Now this 8 would cancel out with that 8. So it looks like I'm just left with a 3 for that one. Let me flip it around now. I want to do A subtract B. All right, I'm just going to start here with this 5. The 5 stays. 6 cancels out when I do the subtraction. 7 stays, but the 8 would get canceled out in the subtraction. So this is going to be 5, 7. But I've got to combine these together into a union. So it looks like my answer should be 3, 5, and 7. So let me go and enter that and see if that's right. 3, 5, 7. Looks good. All right. Do another one maybe. All right. Here, this one's a little tricky. So this one is saying A X is the set of integers. Excuse me, Z is the set of integers. Think of that as all positive and negative numbers. And it says here, X is an integer multiple of 4. All right, and they're asking me for B intersection A complement. Now, this complement, this bar, means the complement. Let's say A was the set of even numbers. Set of even integers, let's say. A with a bar on it would be the set of odd integers. Let's say A is the event, it's going to rain today. A with a bar over it would say it's going to not rain today. So the complement is really all of the elements that are not in set A. All right, so here's what they're asking us. B intersection A complement. Well, I know A is defined as an integer multiple of 4. So that would be numbers like 4, 8, 12, 16, etc. But I need the complement of that. That means this should be not 4, 8, 12, 16, right? It should be other numbers. Let's take set B as 1, 2, and 6. Well, I'm trying to intersect these with numbers that are not multiples of 4. So these values would be like 1, 2, 3. I can't include 4. Then it would be 5, 6, 7. I can't include 8, and so on. Well, if I do an intersection with 1, 2, and 6, I'm going to get a match for 1 and 2 and 6 because none of these are multiples. So let's see if that's right here. So this should be 1, 2, 6. 1, 2, 6. Okay. All right, let's do 1 or 2 more. All right, so this one is a little tricky. And really, you have to take these, one step at a time, of course. And when you see a parenthesis like this, parenthesis is telling you what operation to do first. So what they're giving me here is C subtract B, and then the symmetric difference with A. All right, well, let me do C subtract B. So here is C. I'll write it up here. 1, 5, 6. Here is B. 2, 3, 4. All right, let me do the subtraction. 1 stays in the subtraction. 5 stays and 6 stays. Right? Because they're not getting canceled with any elements from set B. All right, I need to do the symmetric difference with set A. Set A is 4, 5, 8, 9. So remember, what that symmetric difference means, do the subtractions 2 different ways. So I'm going to take 1, 5, 6. Let me do it. 1, 5, 6. And I'm going to subtract 4, 5, 8, 9. The 1 stays. The 5 gets canceled out. The 6 stays. All right, so that means I have 1 and 6 for the subtraction going that way, but I've got to OR it. Remember, this means union with the subtraction going the other way. So let me do the subtraction going the other way. 4, 5, 8, 9, subtract 1, 5, 6. The 4 stays, the 5 gets canceled out, the 8 stays, the 9 stays. So this is going to be 4, 8, 9. So the union, of course, is all of these together. So 1, 6, 4, 8, 9 should be my answer. And this one, let's try it. 1, 6, 4, 8, 9. Remember, the order doesn't matter. Looks good. Let's see, I guess there's one more. Let's do this one. Again, take these, one step at a time and take your time on this. So let's write down what they're asking us for here. They say C intersection B minus A complement. Now, the parentheses around C minus B tells me I got to do that operation first. So let's do that. All right, let me write down C here. C is 249. And B is 236. And I want to do this subtraction. 2's cancel out. 4 stays, 9 stays. So this is 4, 9. And now they're asking me to subtract the complement of A. And notice it's telling me A are going to be even numbers. So that means the complement is odd numbers. So I would be subtracting all the odd numbers, which is 1, 3, 5, 7, 9, 11, etc. Well, if I do this subtraction, 4 is going to stay because there's no 4 back here to cancel out. But this 9 is going to get canceled out with the 9 in that complement of set A. So when I do this subtraction, the only thing that's left is a 4. So I think my answer to this one should just be the number 4. Let's check it out. 2. Okay, so let me check what happened here. Oh, I'm sorry. I wrote the problem down wrong. Let me do it again. Did they change the problem here? Let me do it again. It looks like I might have written, it was C intersection B, I think. So let's start over again. Sorry about that. C intersection B. Subtract A bar. All right. Well, C intersection B. That's asking you for any elements that are in common between C and B. It looks like only 2 is going to be in common, right? So this is a 2. And I got to subtract any odd numbers. Well, of course, when I do the subtraction, the 2 is going to stay. So the answer should just be 2 for this one. All right, folks, hope this is helpful as you're working here in Module 1.